Hi everyone. Now in this session we are going to discuss few more numericals based on mass volume relation. Mass and volume relation. Here the point to be recollected from for this is volume occupied by 1 mole of any gas 1 mole of any gas at STP. Volume occupied by 1 mole of any gas at STP is 22.7 liters, right? And old STP conditions, that is according to American standard conditions, old STP conditions, it is 22.4 liters. Already we discussed about these STP values in the previous classes, right? In most of the numericals and reference books they are giving this one, but as per NCERT we have to follow 22.7. But we may use both the values while solving the numericals, right? Now a small question on this. Calculate the volume of oxygen required for the combustion of some 1.28 grams of ethane. Calculate volume of oxygen required for the combustion of 1.28 grams of ethane. Like this they will give a question. As usual, yesterday's class we discussed, no? Like we have to get the chemical process about which they are dealing with. Combustion of ethane. Ethane combustion means C2H6 on combustion giving carbon dioxide plus water. C2H6 plus O2 gives rise to CO2 plus H2O. On balancing 2 carbons 2 and 6 hydrogens 3, 4 plus 3 7 oxygen atoms, 7 by 2 into 2 7 oxygen atoms. So this is a completely balanced equation. Got it? Now in this equation the question is dealing with which two substances. They may be reactants or products or reactant and product. Which two substances or what are the substances with which the question is dealing with. That's the point you have to notice. Calculate the volume of oxygen. Underline this. Volume. Right? Required for the combustion of 1.28 grams of ethane at STP. At STP. 1.28 grams of ethane means underline this mass. So this is a question dealing with mass volume relation. But suppose we are following 22.4 liters value for our easy calculation part. Okay. So mass volume relation. Now this is a question based on mass volume relation as per the balanced equation at STP conditions. At STP conditions, what mass requires what mass? What volume? What mass requires what volume? That's the point immediately we have to notice. What is that? What's the molecular mass? 1 mole? No. Mass of 1 mole is molecular mass. 12 to 24 plus 6, it is 30. So as per equation at STP conditions, 30 grams ethane requires how many moles? 3.5 moles of oxygen. Every 1 mole occupies 22.4 liters. 3.5 moles occupies 3.5 into 22.4 liters. Right? So 30 grams requires 3.5 into 22.4 liters. 3.5 into 22.4 liters. When 30 grams needs 3.5 into 22.4 liters, then 1.28 grams of ethane requires how many liters of oxygen? This is what we have to find. This is the point we have to calculate. How? Crisscross. So the volume of oxygen required is 1.28 into 3.5 into 22.4 over 30. So these many liters. We have to simplify this. This is a simple mathematical calculation part, right? So in this way, sometimes we have to deal with the calculations based on mass and volume relations. Calculations based on mass volume relations, right? So this is one question. So let us see one more question of this type. Right? Now we will discuss another numerical of this model. See, calculate the volume of carbon dioxide liberated by the combustion of we'll take some value 2.56 grams of methane at STP. 2.56 grams methane at STP. You can use, depending on the options given in the question, you can use 22.4 liters or 22.7 liters. That is in competitive exams. This choice will be there in competitive exams. They may give the option in 22.4 or 22.7. Most of the cases 22.7 is a standard value. Okay, they won't cross that. And even NCERT PU questions also, answer is with respect to 22.7 only. But in some reference books you may notice 22.4 value. So do remember that point. Old STP condition gram molar volume is 22.4 liters and new STP conditions according to IUPAC is 22.7 liters. You should have a knowledge of both the values. Understood? Now you see, calculate the volume of CO2 liberated by the combustion of so many grams of methane at STP. I told you already, when this sort of numerical is given, what we have to do? Read the question properly and first you get the procedure, means about what process the question is given. What's the process? Combustion of methane. So methane on combustion giving carbon dioxide plus water. Any hydrocarbon on combustion gives carbon dioxide and water, you are aware of that point. Now, volume of CO2 required or liberated, this volume we have to deal with by the combustion of so many grams of methane. This mass we have to deal with. So now we have to find mass volume relation. As per equation, is it balanced? We have to check immediately. 4 hydrogens, 2 to the 4 hydrogens, and 2 plus 2, 4 oxygen atoms, 4 oxygen atoms. It is a balanced equation now. Now, in this balanced equation, as per STP conditions, in this equation, as per STP conditions, what mass is giving what mass? What volume? What mass is giving what volume? You have to notice properly. Mass means 1 mole of methane. What is the mass? 16. 12 plus 4. 16 grams is giving 1 mole of any gas at STP occupied. Let us take NCERT value. This time NCERT value. 1 mole of any gas at STP occupies 22.7 liters. Isn't it? So 16 grams is giving 22.7 liters. Then 2.56 grams methane will give how many liters? So use the crisscross method. 2.56 into 22.7 by 16. So you have to simplify this. Right? And I think it is 16. 16 is 256. You can simplify that in that way. So calculation part is it may vary from student to student. It depends on their logic, right? So this is how we can calculate volume of CO2 when certain mass of gas is subjected to combustion. So this is one model, right? Now another model, our next model of questions is calculations based on volume relations. Volume means for both the compounds we have to deal with the volumes only. Understood? So let us see the next model of questions. Okay, now we are going to deal with calculations based on volume relations. See, start with a question. Calculate volume of oxygen required for the combustion of 5.6 liters of ethane at STP. 5.6 liters of ethane at STP. See, by looking at the question, you have to justify whether the question paper sector is following 22.4 liters or 22.7 liters. Like 22.7 and 22.4. 22.4 half is 11.2. This is 11.35. Yes, and this is 5.6. Its half is 5.6. What is its half? 5.5 plus 0.175. Right? 5.675 like that. See the value? It varies. By looking at the corresponding value, you can easily assess which value they are following. Now in this question, they are following 22.4 liters condition. So it's for our discussion only. By discussing several times in this way, really we can memorize these points. Otherwise, in a flow or in a hurry to solve the question quickly, we may neglect these points. That's why again and again I am reminding you about those values. Old STP conditions is 22.4 liters and IUPAC STP conditions are 22.7 liters. Okay. Now this question is dealing with the 22.4 liters value. Okay, from this value we can assess that one. Now volume of oxygen required for the combustion of ethane. What's the chemical process dealing with here? Combustion of ethane. Write the corresponding equation. C2H6 plus O2 gives rise to CO2 plus H2O. Right? 4 plus 3, 7 oxygen atoms, 7 by 2 oxygen atoms. Finished. Now in this balanced equation, the question is dealing with which two compounds? Volume of oxygen required for the combustion of volume of ethane. Volume of oxygen required for volume of ethane. So as per equation at STP conditions, what volume is giving what volume? 1 mole at STP occupied 22.4 liters. Now for this question we are following 22.4 liters thing, right? 1 mole at STP occupied 22.4 liters. Requires 22.4 liters requires how many liters of oxygen? 3.5 moles here. 7 by 2 means 3.5. When 1 mole of oxygen occupies 22.4 liters, 3.5 moles occupies 3.5 into 22.4 liters. When 1 mole of oxygen occupies 22.4 liters, 3.5 moles occupies 3.5 into 22.4 liters oxygen. Now common value is 22.4 liters by cancellation. Every 1 liter requires 3.5 liters. So 1 liter requires 3.5 liters oxygen. Therefore, we are asked to find out 5.6 liters. Therefore, 5.6 liters requires how many liters of oxygen? How do you find? Crisscrossing the way. 5.6 into 3.5 by 1. So this is volume of oxygen required for the combustion of so many grams, so many liters of ethane. See the same equation. Sometimes they may ask mass relation, mass volume relation and volume relation. This is how to solve. So let us see one more question of this type. Okay. See now. Right. Now we'll discuss with one more question. See, calculate volume of CO2 liberated. Volume of CO2 liberated during combustion of 7.2 grams of glucose. 7.2 grams of glucose. Volume of CO2 liberated. So glucose formula is at STP. So as it is not specified, as I said, this is all based on competitive exam approach, JEE, mains and NEET only. If it is a PU numerical, definitely we have to take 22.7 liters. I am specifying once again. See, if it is a PU concept, PU exam or PU numerical, follow 22.7 liters without fail. Okay, but if it is a competitive exam, that depends on the option. Suppose first option may be given as 22.4 liters, 11.2 liters, 5.6 liters, and fourth option is given as 2.8 liters. By looking at the options, you can easily justify they are following which condition: 11.2 liters, 22.4 liters, or 22.7 liters, 22.4 liters are related values, right? Instead, if they give the volume values like, first one is 22.7 liters, second one is 11.35 liters, and third one is a relevant value, then we have to understand that they are following IUPAC STP conditions. Okay, this point of observation is very, very important and required. Okay, otherwise you may go to the wrong approach, wrong answer. Now, volume of CO2 liberated during combustion of 7.2 grams of glucose. This is at STP conditions. Now, solution is, the process is what? Combustion of glucose. Glucose C6H12O6 plus O2 gives rise to 6 moles of CO2 plus 6 moles of H2O. 12 plus 6, 18 oxygens. 12 plus 6, 18 oxygens. So all atoms are balanced. Now, what is our next step? Read the question properly. Volume of CO2 liberated. Underline that. Volume of CO2 liberated during combustion of some mass of glucose. So underline this, mass. So this is a question based on which relation? Mass volume relation. Now, according to this balanced equation, as per the balanced equation at STP conditions, what mass is giving what volume of CO2? That's it. What mass is giving what volume of CO2? What's the molecular mass of this one? 12 into 6 plus 12 into 1. This is 6 carbon atoms. 12 into 6 plus 1 into 12 atoms plus 16 into 6. It is 96 plus 12 plus 72. How much it is? 96. 98 plus 10. 108. 110 plus 70. 180. So 1 mole. Molar mass we have to remember anyhow. 180 grams. See. 180 grams of glucose is giving 6 into 22.7 liters CO2. 180 grams of glucose on combustion is giving 6 into 22.7 liters of CO2. Then we have to calculate for what mass of glucose? Then 7.2 grams of glucose. 7.2 grams of glucose on combustion gives how many liters of CO2? Crisscross. 7.2 into 6 into 22.7 over 180. So this will give us the volume of CO2 liberated during combustion, right? So you need to follow step by step. Okay. Approximately it is see 18 threes, 18 twos how much? 3.6. 18 twos 3.6. 18 fours 7.2. So 18.4. 18.4. We can make the calculation simpler actually. 6 fours 24. 2.4. 2.4 and this is 2.27. By 10 is there. So 2.4 into 2.27 approximately. Like that, 25 into 25 is 625. Approximately it will be around 5.44 liters. Right? So you should follow some tips also for the easy calculation. If you spend more time on multiplying each and every factor, it takes more time. We have to save time in competitive exams. Right? Now, when such a question is given based on mass volume, so sometimes they may give some lengthy calculations. We have to practice that, how to solve it simply. Understood? So this is one numerical. Now, what's our next numerical? Sometimes they may include one numerical related to another. So far we are doing only one numerical. Sometimes they may give a numerical in which we have to solve another numerical related to the previous equation. Understood? So we will see the next model. Okay. Now our next question is calculate mass of limestone. Calculate the mass of limestone required to decompose calculate the mass of limestone required to decompose to liberate CO2. Calculate the mass of limestone required to decompose to liberate CO2, which is required for the conversion of 0.1 mole of sodium bicarbonate to sodium carbonate. Sodium bicarbonate to sodium carbonate. This is the question given. Like this, sometimes an unknown equation will be given. So by practice only we have to overcome that, and by the time you complete lesson by lesson, you will come to know what is the relevant chemical equation. Okay. Now read the question properly. Limestone is to be decomposed to give CO2. You know that limestone means what? CaCO3. And that on decomposition gives what? CaO plus CO2. So that liberated CO2 is required somewhere, is getting utilized somewhere, required for the conversion of 0.1 mole of sodium bicarbonate to sodium carbonate. So whatever the carbon dioxide required for this process, to liberate that amount of, that volume of CO2, how much limestone is to be decomposed? Whatever the CO2 required for this conversion, to supply that CO2, what mass of limestone should be decomposed? See, understand the question properly. Read it 4-5 times, no problem. But if you understood the problem, if you got that problem clearly, you can easily answer that one. See once again. For the conversion of sodium bicarbonate to sodium carbonate, we need carbon dioxide. That's what given. The carbon dioxide which is required for the conversion of. For the conversion of sodium bicarbonate to sodium carbonate, we need some CO2. To supply that same amount of CO2, what mass of limestone is required to decompose? So what we have to find out first? NaHCO3 conversion. NaHCO3 plus H2O plus CO2 gives rise to Na to CO3. So this you are going to study in the preparation of sodium carbonate by Solvay's process. In first year, in 11th class only, you are going to study this equation in the preparation of sodium carbonate by using Solvay's process. Okay, don't worry. Sodium bicarbonate, when dissolved in water saturated with carbon dioxide, gives sodium carbonate. It's a reversible process also possible, but this doesn't decompose. Okay, so we can get this by a different procedure. Okay, now sodium carbonate do not decompose thermally. That's not the point I said. Okay, now you see, for the conversion of 0.1 mole of sodium bicarbonate to sodium carbonate, whatever the CO2 required, that CO2 will be obtained from what mass of limestone? See, 2 moles of sodium bicarbonate need 1 mole of CO2. 2 moles of sodium bicarbonate needs 1 mole of CO2. When 2 moles needs 1 mole, then 0.1 mole needs how many? How many moles of CO2? 2 needs 1, 1 needs half, and 0.1 needs 0.05 moles CO2. When 2 needs 1, in this half is required here. In this half we need, right? So number of moles of CO2 required for the conversion of this sodium bicarbonate to sodium carbonate is 0.05 moles. Now this 0.05 mole CO2 can be obtained from how many grams of limestone? That is a continuation problem. See, calcium carbonate, CaCO3 on thermal decomposition giving CaO plus CO2, right? Now 100 grams, its molecular mass is 100 gram, formula mass. 100 grams is giving 1 mole of CO2. Or in a reverse way you take 1 mole of CO2 is obtained from 100 grams, then 0.05 moles CO2 can be obtained from how many grams? So crisscross method, 0.05 into 100 by 1, that is 5 grams of CaCO3. Answer is 5 grams. Okay. So in this way, question in another question, one question in another question may be merged and will be asked, and there is a scope of asking this in PU examination as well as competitive examinations. By practice only we can increase the speed. Understood? Go through these models of numericals slowly and properly, and you can raise a doubt in the questionnaire, right? It may take some time, but definitely you will get the answer, right? So we will discuss the next question. Right? Now let us do a different model question. Now this is a bit logical actually. See, calculate mass of lime obtained by thermal decomposition of mass of lime obtained by thermal decomposition of 100 grams of 90% pure limestone. 90% pure limestone. So far this percentage purity is not given. Means what? It is 100% pure. This percentage purity is not specified in the question, means it is 100% pure sample. Now in this question 90% pure is given. Okay, as usual procedure is same. What is the procedure? Thermal decomposition of limestone, CaCO3 on thermal decomposition giving CaO plus CO2, right? Now according to this mass of lime, its mass, and even this is also mass. What is the formula mass of this? 100 grams. 100 grams is giving 56 grams lime. 100 grams of limestone is giving 56 grams lime. When this will be the answer when 100 grams itself is a pure sample. 100 out of 100 is a perfectly calcium carbonate. There is nothing else in this. Then 56 will be the answer. But in our question, what is the percentage purity? 90% pure. Means out of 100 grams, only 90 grams is the CaCO3 compound. Remaining 10 grams is some impurity. So during decomposition, 100 grams is decomposing or only 90 grams is decomposing? Yes, only 90 grams, whichever the purity specified, 90 grams means out of 100 grams, 90 grams, 90%, no? So therefore 90 grams on decomposition gives how many grams? Crisscross method. 90 into 56 by 100. So it's a simple calculation, right? 45 plus 4, right? 504 by 10. 50.4 grams of lime will be found. So this is percentage purity numerical model of numerical questions. So rest of the models we will discuss in the next class, right? Go through these numericals and raise questions and immediately. So I will respond for your queries, right?